Okay, let's look at question 3C. Find the absolute minimum value and the absolute maximum value of g on the interval from -4 to 12. Justify your answer. Okay, so last time when we were talking, we mentioned how the max and the min have to occur when your function has sort of this effect, where it's the original. We're talking about the original function, right? Has this effect or this effect, and these occur when you have a change in slope. So if your slope of your original function is changing from positive to negative or negative to positive, you have this effect. Okay. In addition, if you're checking for absolute minimum values and absolute maximum values, you also have to check endpoints. And the reason why we also have to check endpoints is because we don't know what's going on, right? So if your function starts off super high and then goes down and goes like this and something like this, clearly the endpoints are going to illustrate the maximum and the min are going to be the maximum and minimum. But you don't know because we don't have the actual graph. So we simply have to test them. Okay, so what do we need to do? We need to state where we have absolute maxes and mins. Okay, so how do we figure out where that's going to occur? So remember this graph, the graph of f of x, we established earlier that g prime of x is f of x, right? So, and if you don't see that, then refer back to a previous video. So we know that g prime of x equals f of x. So what that means is that we're looking at the value. So we have to check, obviously, -4. And so maybe the best way of doing this is just to make a list of values to test. So we're going to test -4 because that's an endpoint. Now, from here to here, these are negative values, these are positive values. So you have a change here, right? So you can check, we want to check -2, okay? Then right here, we also, well, I've seen different things. It's not going to be here because everything is positive, so there's not going to be a max or a min. But we'll go ahead and list this value. It actually will help us in the next part as well. And then we'll test here, okay? And this is where it changes from positive to negative, right? Again, we're looking at the y values. You see the y value is positive here, the y value is negative here. So we're going to test that value. Then we'll also test at 10. Again, it's not going to be at 10. And then we'll also have to test the endpoint at 12. Okay, so we're going to test each of these values. I've seen this noted, looking at various videos, as the candidate test. Okay, so I don't know if you guys have talked about that, but I've heard it called that. And again, I'm really testing these critical points. So the test is going to ask you to you have to say what you're doing. So I have to say something to the effect that the absolute max and min occur at critical points or endpoints. Okay. The critical points are x equals -2, x equals 2, x equals 6, and x equals 10 because g prime of x equals 0 at those points. So again, remember we say that when your zeros represent critical points, when the function is equal to 0 or undefined is when critical points occur, and that's where it's happening here. So again, I can't iterate this enough. Like, you know, it's changing from negative to positive here, and here we're changing from positive to negative. So your critical points are your max or min is either going to be there or your endpoints. But we'll go ahead and check all the points. Okay, so let me do this on another page here. So how do we figure out the value of the figure at each of these points? Well, because it describes them as, let me zoom this out a little bit, because they say g of x, because they say g of x equals the integral, then you know that the area under the curve is what we're going to be looking at. Okay, so let me go ahead and blow this up a little bit so you can have a more visual representation of the graph. Let me take away my circle. So all I got to do is find the area under the curve. Well, what's the area under the curve? Well, we have a triangle here, I got a triangle here, I got a triangle here, I got a triangle here, and I got another triangle here. So what's the area of this triangle? Well, we know that from 0 to -4, that's a distance of 4. From -4 to -2, that's a distance of 2. The area of a triangle is 1/2 base times height, so it's going to be 1/2 the base, which is 2, times the height, which is 4, and this is going to give me 4. So we know that this is 4. Because these share the same dimension, I also know that this is 4. For the bigger one, the base is 4, the height is 4, so we'll do 1/2 4 times 4, which is going to give me 8. Half of 4 is 2, 2 times 4 is 8. So we know the bigger one is going to be 8, let me use a different color, 8, and this will be 8, and this will be 8. Okay, so those are our areas, and now all we got to do is solve the problem. So here's a little diagram of what we've had thus far. I filled in the areas, I've drawn the picture, and we just need to find the areas. Okay, so if I'm asking you to find, we're looking at this value here, right? 2, and let's start with -4. So we're going from 2 to -4 of ft dt. How do we go about doing that? Well, normally we have the lowest value on the bottom here, so we're going to say, we're going to put a negative, which allows me to switch the interval, okay? And then all I have to do now is figure out what -4 to 2 is. -4 is 4, and then 2 is going to be 8. Keep in mind though that because 4 is under the graph, it's negative. So this gives me 4, but keep in mind that all of this is being negated. It's being negative. So all of this is equal to -4. So this tells me the first part is -4. Some students like to say, well, look, if I'm going from 2 to -4, do I really have to do all that math? Well, no. All you actually have to do is say this is 8, this is 4, they're different, so you subtract. Because I'm going to the left, it's negative. Okay, again, from -4 to 2, that's really what we're asking you for, right? You just say 2 to -4. I take these, because the top one is positive, bottom was negative. I subtract them. 8 minus 4 is 4. Because I'm going to the left, it's negative. So it becomes -4. And we can work our way through like that. So let's just go ahead and do that from here on out. So we're going from 2 to -2. That's 8. So if we make it negative, it becomes -8. From 2 to 2 is clearly going to be 0. You don't have any area here. From 6 to 2, that's an area of 8. From 10 to 2, that's an area of 8 minus 8, which is 0. And from 12 to 2, it's going to be, you have 8 minus 8 and then -4. Okay? So now when we look at this, we can say that the maximum value is 8, the minimum value is -8. And that's our answer. Okay? If you want the formal way of writing this out, we can say, let's go down here, the absolute minimum is -8, and absolute maximum is 8 by the candidate's test. Okay, again, I want to stress here, kind of putting all these ideas together, right? If we're going from a negative to a positive, right, this is probably negative to a positive. We're talking about slope here, right? I'm talking about the y values here. Then that means you're going from negative, means you have one slope going down, and then positive going up. It makes sense that the smallest value would be here, and then here, if we're going from positive to a negative, this means you're going from a positive value to a negative value. This means you have kind of a hump like so, and that occurs at 6 to 8. So I can look at this problem. I'm giving you all the values because having these helps us out in future questions. But the reality is that you know it should be happening here and here. Something else that's useful I always find on big tests like this is it's not just about getting the answer, but if you can understand like where the answer is coming from, and if you have multiple ways of seeing that the answer is what the answer is, it makes your life easier. Anyways, that's the answer. Hopefully that makes sense. I'll see you all in the next video.